Greetings, Calc 3 students. This video covers chapter 14, section 0.6, so section 14.6. And I'm going to specifically look at homework question number 5. So we're asked to find the directional derivative of a function f at the given point and some angle. So we are given that we have the function, two variable of x and y, of 2y e to the negative x. That's the function we're given. And we're asked to find that directional derivative at the point 0, 9. And we have a direction angle of theta equals 2 pi over 3. So the first thing that I'm going to do is write down the directional derivative formula in this context. So that would be the derivative with respect to u, and then often we actually, to be precise, will kind of bold this part down here, usually is what we do, of the function f of x and y is equal to the partial derivative of x and y times the cosine of theta plus the partial derivative of f with respect to y of x and y times sine of theta. So that formula we can use, and the reason I know to use that formula is, well, we need a unit vector. That's what this u stands for, and we're not given a unit vector, but we're given an angle, and I know that the unit vector certainly does exist with cosine of theta, sine of theta. That is a unit vector, and so that's the unit vector we're given, and implied that we were given because we were given this angle to put in there. Okay, so what I need to do then is figure out what the partial derivatives are of f with respect to x first and then with y. So the partial derivative of f with respect to x is equal to minus 2y e to the minus x, and the partial derivative of f with respect to y is just equal to 2 times e to the negative x. So once again, when I'm taking with respect to x, I pretend that this is a constant, and the derivative of e to the negative x is minus e to the negative x. And then I would multiply that times the constants, and so that's what I did here. And then when I take the derivative with respect to y, I'm holding this to be a constant, so that means this whole term is a constant. And when I take the derivative with respect to y, this will just be 1, so I'll have 1 times 2 times this constant, and so that simplifies to that. Okay, so then my directional derivative of f of x and y is equal to the partial derivative of f with respect to x, so minus 2y e to the negative x times cosine of theta. And then I add that to the partial derivative of f with respect to y, so 2e to the minus x times sine of theta. Okay, and then specifically with this point 0, 9, and at this direction 2 pi over 3, we'll plug those values in. So x is 0, y is 9, so negative 2 times y times e to the minus 0 times cosine of 2 pi over 3 plus 2 times e to the minus 0 times sine of 2 pi over 3. And then I simplify that, so that's equal to, oh, I accidentally wrote a y there, didn't I? So let me change that to a 9, because y is equal to 9 in this step. And so 2 times 9 with a negative sign up front is negative 18. And e to the negative 0 is just 1, and I'll write that for emphasis here. So times 1. And then cosine of 2 pi over 3 is minus a half. And then plus 2 times e to the negative 1, again, is just 1. Or e to the negative 0 is just 1. So 2 times 1. And then sine of 2 pi over 3 is the root 3 over 2. So then when I simplify that, I get 9 plus root 3. And that is my final answer. Okay, so if you have any questions, please let me know.